Hello class, this is a video tutorial on further trigonometric identities and equations, part 1. In this video, we'll be looking at the sum and difference of angles. So from year 8, here are all the identities we have already encountered. Okay, if you don't quite remember what these mean, it's best that you go back and revise them. But for these, for this video, we'll be introduced to the different identities and shown how we can use one of them to solve some trigonometric equations. So here are the next sets of trig identities we will be covering. They are the sum and difference, the double angle, product identities, T formula, and the auxiliary angle form. By using these, more difficult trig equations can be solved and graphed. So let's get straight to it. Here's the first example that we're going to be solving. You can go ahead, pause the video and try it yourself. But you'll quickly find that we don't have any techniques yet that we could do this, because normally we would try and get some sort of expression with tan. So if we could get tan of x plus pi on 4 is equal to 2 by dividing by this, that would be great. Except we can only get tan of x plus pi on 4 if this were also x plus pi on 4. But for this, we have nothing that we can do just yet. So the first identity that we need to remember is this one here. It's the sum and difference identities. So if we have sine of a plus b, it becomes sine a cos b, so that's a multiplication in between, plus cos a sine b. Now, the order of these plus and minus are important, because if this were plus, we take the plus. If it's the difference of the angles, this would also be minus. But if you take a look at the cosine, it's the same thing, cos of a plus b. But if it's cos a plus b, it becomes cos a cos b. That's a multiplication in between, minus. So if it's a plus, we take the minus instead. So cos a times cos b minus sine a sine b. But if it's the difference of two angles using cosine, so minus, so a minus b, it becomes cos a cos b plus sine a sine b. And it's the same case for tan. But in this video, we're mostly going to be looking at sine and cos being used. Here's our next example, but you'll see that in the next video for this, because it's going to be rather long, simply because I'm taking you through each step. So here we go. So the first step we need to do is expand by using these identities here. So sine of a plus b, we're going to get something that should look like that. So it will become sine of a, which is x, times cos of b, which is pi on 4. Since it's plus, we also take the plus from the identity, plus cos of a, which is x, times sine of b, which is pi on 4. So we have successfully used the identity to expand to this. Moving forward, we have cosine this time, so equals 2 times cosine of a minus b, so that's a minus b. Using this identity, we get cos a cos b. So cos of a is x, cos of b is pi on 4. Now take a look again. Because it's minus, we take the plus. So plus sine of a, which is x, times sine of b, which is pi on 4. And once again, we've successfully expanded using the identity, the right-hand side. From this point forward, it just becomes trig equation solving. So you can use what you remember for the exact triangles. Pi on 4 is 45 degrees. So a right angle triangle with 45 degrees, that's 1 root 2. Cos of 45 is 1 on root 2. Now since there's a multiplication here, that's going to be sine of x times 1 on root 2, which we can simplify as, sine x on root 2. Same case for sine pi on 4. Sine pi on 4, opposite over adjacent. That's cos x times sine pi on 4. It's going to be cos of x over pi on 2. And that's the left-hand side simplified. And we do the same thing for this. Cos pi on 4, it's going to be 1 on root 2, because that's times. It's going to be cos x on root 2, but now since we're going to expand this, it's going to be 2 cos x over root 2. Same thing for this. Sine pi on 4, 1 on root 2, plus 1 on root 2 times sine on x, multiplying by the outside factor. And here we have this trig equation. To make this easier for us, we'll multiply everything by root 2. That should be sine. And moving everything to one side. So sine x minus 2 sine x, negative sine x, cos x minus 2 cos x, negative cos x is equal to 0. If ever you come across where we have sine and cos like this equaling 0, best thing to do here is dividing by cosine. Because if we do that, sine over cos is going to be tan of x. Cos divided by cos is negative 1. Moving tan to one side, we get tan x equals negative 1. You can try to type this into your calculator. Oh, sorry, it should actually be x is equal to tan inverse of negative 1. Now that's what you type into your calculator. If you do this, you should get x is equal to negative 45. However, because of the domain, we can't accept negative angles, and it should also be in radians. So to convert this, we need to go back to our unit circle understanding. Since it's negative 1, we need to know where tan is negative. Tan is negative in the second quadrant and the fourth quadrant. And we're looking for an angle like this, where this is 45. Well, if that's 45, what angle is this one? Well, that there is just 180 minus 45. And likewise, in the fourth quadrant, we're looking for an angle like this, 45 degrees. But what we're really looking for is this angle here. Well, that there is 360 minus 45. This should get you 135 degrees and 315 degrees. But we're almost done because we need to now convert this into radians. To do this, from degrees to radians, we multiply by pi on 180. So 135 divided by 180, that should give us 135 divided 180 is 3/4. But since we're multiplying by pi, we get 3 pi over 4. Likewise with this, 315 over 180, we get 7 over 4 times pi, 7 pi over 4. And that there is our final answer. So I hope that gave you an insight into how we can use these trig identities to first expand an equation, and then solving it using regular trig equation skills. Hope to see you in the next video where I take on this next example here. You can give it a go yourself before we answer it. I'll see you then.